So let's talk more about the periodic table. In 1869, Dmitri Mendeleev noticed that certain groups of elements had similar properties. At this point in time, we knew about a bunch of different elements, but they hadn't really been pulled together in an organized way. So Mendeleev found that when he listed the elements in order of increasing mass, there were properties that repeated in a periodic pattern. So periodic means to exhibit a repeating pattern. So a periodical at the library is a magazine or a journal that comes every month or every week in a repeating pattern. So the periodic table refers to this repeating pattern. So he did something like this, where he listed the elements in order of increasing mass, and here the elements that have the same color, the orange ones, they had similar properties. So helium and neon and argon had similar properties. And it happened in this repeating pattern. It's a little bit like a piano keyboard, where you have middle C, and then you go up an octave, and there's another C. It's just a harmonic of the first one, and you have this repeating pattern. So he summarized these observations in what came to be known as the periodic law. When the elements are arranged in order of increasing mass, certain sets of properties recur periodically. And so he used this idea and rearranged the atoms into a table. The elements. So this is an example of a simple periodic table, just the first 20 elements. So he put them so that elements with similar properties were in columns. So he lined it up so all the blue ones are on top of each other, and the purple ones, these guys we're not going to talk about, but the green ones and the orange ones. So Mendeleev generally gets credit for being the father of the modern periodic table. So his table had some gaps in it because he was lining up things by recurring properties, and there were some places where there weren't elements to fill in the gaps. And so he predicted that elements would be discovered to fill in those gaps, and he predicted their properties as well based on the properties of the elements around them. So he predicted an element he called eka-silicon. Eka just means below. So this would be filling in a gap below silicon on the periodic table. That was discovered in 1886 by a German chemist who named it germanium after his home country. Clemens Winkler found that. So here is a periodic table showing when the different elements were discovered. So here's germanium. This was discovered after silicon. So when Mendeleev was putting together his table, this element wasn't known yet. And so he predicted that an element would be found. And this is how in 1869 Dmitri Mendeleev completed the first periodic table. You guys have heard of Tetris, right? Video game, yeah. So it's just kind of funny. Nobody ever laughs. It's so sad. So one small difference from Mendeleev's periodic table is that we now understand that the ordering principle isn't the mass, it's actually the atomic number, the number of protons. But when Mendeleev did this, he didn't know that protons existed or what they were. So we'll excuse him from that. Our modern periodic table also has more elements than his did because elements have been discovered and made since his time. So in the periodic table, there are some major divisions, and this one illustrates a couple of those. There's a stair-step line here separating boron and aluminum, and then just going down at a diagonal. That's the line that divides the metals from the nonmetals. So to the left of that, which is most of the elements, these are in the light yellow here, these are all metals. And to the right of that stair-step line, these in the green are nonmetals. The ones exactly touching the line, except for aluminum, are considered metalloids or semi-metals. They're kind of like metals, but they're not exactly metals. So based on a location in the periodic table, you should be able to tell me whether an element is a metal or a non-metal or a metalloid. So the line is on the periodic table. You can get confused. Okay, I know one side is metals and one side is non-metals, but I can't remember which is which. Well, pick an element that you know. How about iron? Is iron a metal? Sure, we know that from life experience, right? Well, here's iron. It's on the left side. That means all of these guys are metals. Okay. All of these guys are non-metals. Now, hydrogen is green, but he's hiding over here with the metals. We're going to see that hydrogen is like the baby brother of the element family, and he's just like breaks all the rules, right? He's like my Andrew, just turned 9 yesterday, and if you ask his older siblings, they'd say, yeah, Andrew gets away with a lot of stuff that you would have just taken us out for, because he's the youngest one, right? Hydrogen's the smallest element, breaks a lot of the rules, so we just have to make allowances for him. Any questions? There's these two lines or two rows down here. It's like, why did those get pulled out? There's an arrow here, and you'll notice a little gap. So we've got our atomic numbers, 55, 56, 57, 72. What the heck? Well, 57, we really should drop down here to 58 and go across here to 71 and then go back up here. That makes the periodic table very long, right? Well, short and wide, right? It doesn't fit on a piece of paper very well, or a screen. The one we have up here on the wall, since our space on the wall is very short and wide, we actually cut this periodic table up and put the lanthanides and the actinides where they belong. So if you wanted this to really be correct, you would take a scissors and cut right here and then put these guys in here, just tape them in. These are uncommon elements. We don't use them very much, and so we just pulled them out and stuck them at the bottom. They're there if you need them, but most of the time we don't. So the classifications: metals, nonmetals, metalloids. These are the characteristics of metals. They are generally good conductors of electricity and heat. They're malleable and ductile. Those are two words you might not be familiar with. Malleable means if you hammer it, it's just going to dent. It's not going to shatter. So if you take a hammer to a piece of metal, you can eventually hammer it out into a sheet. Maybe you've seen videos or pictures of blacksmiths working with metal, right? Ductile means it can be pulled into a wire. Metals are often shiny. They tend to lose electrons. So if an atom is losing an electron, is the charge of its ion going to be positive or negative?
Positive.
It's going to be positive because it's losing a negative charge. So then what's left is extra positives. So metals form positive ions. Nonmetals are kind of the opposite. They are not metals. They're poor conductors. They're not ductile. They're not malleable. They gain electrons when they undergo chemical changes. So they form negative ions. And I find it convenient that nonmetal starts with an N, and so does negative. So nonmetals form negative ions. And then the metalloids or semi-metals are in between. They're kind of like the metals and they're kind of like the nonmetals. Okay? So they're intermediate. They are often referred to as semiconductors because they do conduct electricity and heat, but not very well. They're intermediate. They're semi. What's really useful about semiconductors is their electrical conductivity is highly dependent on temperature. And so they're very, very useful in making electronic devices because you can make very tiny switches out of them. Other divisions in the periodic table. So over here in the yellow and over here in the yellow, elements in those sections are called main group elements. Those are the parts, the columns that stick up. This part down here looks like it sank down. Those are called the transition elements. So you could think of this as one bank of a river, and this is the other bank of the river, and this is the transition from one to the other, if that works for you. But these are the transition elements. We also have some numbers on the periodic table. So the rows are numbered 1 through 7. The rows are called periods, and they're just numbered 1 through 7. The columns are also numbered. These are called element groups. So there's group 1, group 2. Now there's two different sets of numbering. There's the one that the chemists around the world got together and agreed upon, and that's this just 1 through 18, which, you know, that has its advantages. It's very simple. But then there's also another system using letters. So we've got 1A, 2A, and over here the main group elements continue 3A through 8A. And the transition elements have numbers with a B instead of an A. This is what we currently use in the US, and I find it very useful because it helps us to identify valence electrons and charges easier than the other numbers. But the periodic table up here has both numbers, sets of numbers, and the periodic table I'll give you for exams also has both sets of numbers. So groups are columns in the periodic table, periods are rows. Some of the groups, those columns, have special names, kind of like a family name. Remember, the periodic table was arranged originally based on similar properties. So in a given column or group of the periodic table, those elements have similar properties. The noble gases are group 8A. They are generally very unreactive gases. So that's an element group name that you need to know. The alkali metals are the group 1A elements. They're very reactive metals. Next to them in group 2A, the alkaline earth metals. They're fairly reactive, but not quite so much as the alkali metals. And then the halogens in group 7A are very reactive nonmetals. So these guys here, those are the alkali metals. Group 2, alkaline earth metals. Group 8, noble gases. And these are the halogens. So you should know those, the names of those 4 groups. So main group metals, we just learned that metals tend to lose electrons. The main group metals lose electrons to form cations that have the same number of electrons as the noble gas that's closest to them. And the main group nonmetals tend to gain electrons to form an anion with the same number of electrons as the nearest noble gas. I'm just going to jump ahead to the periodic table. So here we have main group elements that are in this main group section. We're not talking about the transition metals here. Main group elements. So lithium, if it loses 1 electron, it's going to have the same number of electrons as the noble gas over here, which is helium. Hydrogen, well, he's just annoying. Fluorine. So we look on the periodic table on the wall, we see that fluorine has 9 protons. Fluorine atoms have 9 electrons. If it gains 1 electron, then it has 10 electrons. What element has 10 electrons as an atom? Neon. So by gaining 1 electron, fluorine has the same number of electrons as the noble gas that's closest to it. Oxygen has to gain 2 electrons to become the same number of electrons as neon. Nitrogen has to gain 3. Here's aluminum, a main group metal. So that's going to lose electrons. It's not going to gain electrons to go this way. It's going to lose electrons. So if it loses 1 electron, it'll be the same as a magnesium atom. 2 would make it like sodium. 3 would bump it around here and make it have the same number of electrons as neon. And we'll see there's a reason why the number of electrons that noble gases have seem to be desired by a lot of these atoms. So let's go back to those slides I skipped. So the alkali metals, group 1A, tend to lose 1 electron, form +1 ions. Group 1 metals form +1. The alkaline earths, group 2, tend to lose 2 electrons, form +2 ions. Group 2, 2+ ions. The halogens in group 7 tend to gain 1 electron and form -1 ions. So if you like the group numbers, you can say for the nonmetals, you take the group number -8. So 7 minus 8 will give you the charge on the ion. The oxygen family, which doesn't have an accepted name, group 6A tends to gain 2 electrons. So again, if you take the group number and subtract 8, that will give you the charge that those atoms have when they become ions. So, summary of that. For the main group elements that form cations, the metals, the charge is equal to the group number. Main group only. For the main group elements that form anions with predictable charges, those would be the nonmetals, the charge on those is equal to their group number -8. And these group numbers that I'm referring to are the ones with the letters, the 3A, 4A, 5A, not the 17 and 18. The transition metals can form lots of different ions, and so we'll talk about those guys later. So group 1A, these elements all form +1 ions. Group 2A, +2 ions. Group 3A, +3. Simple enough, right? Hydrogen is over here. Hydrogen is not a metal, but it does form a +1 ion, and so that's kind of why he's listed over there in the periodic table. Some periodic tables also have hydrogen over here, because hydrogen can also act as the nonmetal that it is and gain an electron. So all of these elements gain 1 electron, have a -1 charge. So you can take the group number -8 to get the charge, but what students tend to like a little bit more is think of this as, maybe a board game. My pointer's stuck. Awesome. Everything's stuck now. So if you want to know the charge of one of these ions, pretend that you're starting over here, like on a game board, and you're going backwards. To the left is usually backwards, right? So this would be 0, and these do not form ions, so they always have a 0 charge. Go 1 space to the left, that's -1. Go another one, -2, -3. So to predict the charges on the negative ions of the nonmetals, you can just start at the noble gases and count backwards. So we want to know what the charge on sulfur is. You start over here, -1, -2. So we can identify the charges of these ions based on their position in the periodic table. I would also add phosphorus in here. What do you think the charge on a phosphorus ion is? -3. So 3-. Very predictable. What about carbon? Carbon isn't shown on here. Stupid pointer. Well, carbon doesn't really form ions. Do you need to know that? No. I'm just not ever going to ask you to predict the charge on a carbon ion because they don't make ions. So you can just use these patterns on the periodic table. Any questions? So predict the charges of the monatomic ions formed by these main group elements. So monatomic just means there's one atom becoming an ion. So nitrogen, what would the charge on a nitrogen ion be? -3. So we find it on the periodic table. We see it's to the right of the stair-step line. It's a nonmetal. It's going to be a negative ion. So we start over here to the right and we count backwards. This is 0, -1, -2, -3. So that would have a -3 charge. So we could write its symbol N3 minus. Or we could say it has a -3 charge. What about this one, rubidium? +1. Got to find it in the periodic table. So it's down here. It's in group 1. It's a metal, so it's going to be +1. There's not really any understanding necessary at this point. It's just following a pattern. There is a very scientific reason behind why they do this, but we'll save that for another chapter. Any questions?